the firing order is the sequence of power delivery of each cylinder in a multi-cylinder reciprocating engine. This is achieved by sparking of the spark plugs in a gasoline engine in the correct order, or by the sequence of fuel injection in a diesel engine. When designing an engine, choosing an appropriate firing order is critical to minimizing vibration, to improve engine balance and achieving smooth running, for long engine fatigue life and user comfort, and heavily influences crankshaft design. Ignition: in a gasoline engine, the correct firing order is obtained by the correct placement of the spark plug wires on the distributor. In a modern engine with an engine management system and direct ignition, the engine control unit takes care of the correct firing sequence. Especially on cars with distributors, the firing order is usually cast on the engine somewhere, most often on the cylinder head, the intake manifold or the valve cover. Various firing orders for different engine layouts. Although the vast majority of automobile engines rotate clockwise as viewed from the front, some engines are designed by the manufacturer to rotate counterclockwise to accommodate certain mechanical configurations. In these applications, the firing order is shown in a reverse order. For the most common inline configurations, this gives firing orders of 1-3-2, 1-2-4-3, and 1-4-2-6-3-5. In addition to the reconfiguration of the plug wires or injector tubes, the valve timing must be accordingly modified. Cylinder numbering and firing order: notes on left, right and front rear. When referring to cars, the left-hand side of the car is the side that corresponds with the driver's left, as seen from the driver's seat. It can also be thought of as the side that would be on the left if one was standing directly behind the car looking at it. When referring to engines, the front of the engine is the part where the pulleys for the accessories alternator and water pump are, and the rear of the engine is where the flywheel is, through which the engine connects to the transmission. The front of the engine may point towards the front, side or rear of the car. In most rear-wheel drive cars, the engine is longitudinally mounted and the front of the engine also points to the front of the car. In front-wheel drive cars with a transverse engine, the front of the engine usually points towards the right-hand side of the car. One notable exception is Honda, where many models have the front of the engine at the left-hand side of the car. In front-wheel drive cars with longitudinally mounted engines, most often the front of the engine will point towards the front of the car, but some manufacturers have at times placed the engine backwards, with number 1 towards the firewall. One notable car with this layout is the Citroën Traction Avant. This layout is uncommon today. Cylinder numbering and firing orders for various engine layouts: in a straight engine the spark plugs are numbered, starting with number 1, usually from the front of the engine to the rear. In a radial engine the cylinders are numbered around the circle, with the number 1 cylinder at the top. There are always an odd number of cylinders in each bank, as this allows for a constant alternate cylinder firing order. For example, with a single bank of 7 cylinders, the order would be 1-3-5-7-2-4-6. Moreover, unless there is an odd number of cylinders, the ring cam around the nose of the engine would be unable to provide the inlet valve open, exhaust valve open sequence required by the 4-stroke cycle. In a V engine, cylinder numbering varies among manufacturers. Generally speaking, the most forward cylinder is numbered 1, but some manufacturers will then continue numbering along that bank first while others will number the cylinders from front to back along the crankshaft, so one bank would be 1-3-5-7 and the other bank would be 2-4-6-8. To further complicate matters, manufacturers may not have used the same system for all of their engines. It is important to check the numbering system used before comparing firing orders, because the order will vary significantly with crankshaft design. As an example, the Chevrolet small block engine has cylinders 1-3-5-7 on the left-hand side of the car, and 2-4-6-8 on the other side, and uses a firing order of 1-8-4-3-6-5-7-2. Note that the order alternates irregularly between the left and right banks. This is what causes the burbling sound of this type of engine. In most Audi and Ford V8 engines, cylinders 1-2-3-4 are on the right-hand side of the car, with 5-6-7 to 8 are on the left. This means that Chevy Generation 1 small block V8 engines and Ford 302 V8s have an identical firing pattern despite having a different firing order. Likewise, the firing pattern is the same for Chevrolet and Chrysler V8 engines with a firing order of 1-8-4-3-6-5-7-2, and for Ford's V8 engines with a firing order of 1-5-4-2-6-3-7-8. An exception is the Ford flathead V8 where the number 1 cylinder is on the right front of the engine but this cylinder is not the front cylinder of the engine. In this case number 5 is the front cylinder. A similar situation exists with the Pontiac V8s 455 etc. Where the cylinders are numbered like a Chevrolet V8 but the right side bank is in front, like a Ford, this puts cylinder number 2 in front of number 1. Odd and even firing order. Firing order affects the balance, noise, vibration, smoothness, and sound of the engine. Engines that are even firing will sound more smooth and steady, while engines that are odd, or uneven firing will have a burble or a throaty, growling sound in the engine note, and, depending on the crankshaft design, will often have more vibrations due to the change of power delivery. Most racing engines such as those in Formula One often have an even firing order, mostly for quicker acceleration, less vibrations, and more efficient exhaust system designs. Most engines that utilize the Big Bang firing order system will often have an uneven firing order. Examples of odd firing engines are any Crossplane V8, Harley-Davidson Evolution engines, 2009 Euro-present Yamaha YZF-01, all Ford V10 engines, Audi V10 FSI, GM Volt 3500 inline 5. Viper V10, Mercedes-AMG V12S, Aston Martin 6.0L V12, Yamaha V-Max and BMAX, Buick 231 Odd 5 V6, and Chevrolet Straight 6 engines. Examples of even firing engines are most current production inline 4s, most current production V6s, all Ferrari production engines, Lotus Esprit V8, Porsche 918 Spider, McLaren M838T engine, Toyota LR engine, and all Lamborghini production engines. Ships. Contrary to most car engines, a ship's engine or a power plant engine is numbered from the flywheel end towards the free end. In ship and power plant V-type engines the numbering is A1 and B1. Where the A bank is on the left-hand side and the B bank is on the right-hand side, looking from the flywheel end. See also, engine configuration, 4-stroke engine, 2-stroke engine, references. 1997 Dakota firing order diagram, external links, firing orders, cylinder numbering and distributor rotation for American V8 engines, an analysis of firing orders and cylinder numbering of V8 engines.